Hi, I'm Lee Teschler with EE World and Design World. I'm here with Steve Subiry from Eaton. And Steve's going to talk to us a little bit about power inductors. Steve, how do you make a power inductor to handle a high current so it still behaves like an inductor? Tell me a little bit about that.
High current inductors usually are able to handle a tremendous amount of current. And one of the ways to allow them to carry all this current is by having a rather bigger conductor, so you have a less resistance and you'll be able to carry more current. One of the best techniques to achieve that while achieving efficiency is by having your magnetic material couple very well with the copper conductor. So while you are transmitting or you're passing a lot of high current, you are being able to also remove a lot of that heat, a lot of the copper loss. And by doing that, you'll be able to behave as an inductor while you are handling different types of current levels.
Interesting. Now, there's a lot of talk about increasing the frequencies of switching supplies and in turn power inductors. How do you make an inductor behave like an inductor as that frequency goes up?
Depending what type of magnetic materials you're using on the inductor, it would allow you to perform and operate effectively a certain inductance value. So there are different types of high current inductors. Some of them are in the what we call the ferrite category. And what it means is you will have different type of ferrite combinations on the cores, but it will also need a discrete gap to allow you to perform at a certain current. The other category will be when you have materials like pressed powder inductors, where you can achieve a distributor gap. The beautiful thing about pressed powder inductors, powder iron inductors, is that distributor gap would allow you to achieve the highest amount of inductance at any given high current range level. So while with ferrites, once you're getting into a higher current level, and depending on the temperature, you can start seeing a roll-off. Now, when it comes to frequency, when you are in the pressed powder inductor category, you are limiting your frequency up to 1 megahertz. If you're using ferrites, you can actually start using or operating at a higher than 1 megahertz, maybe 3 megahertz. And that's where the market has been going. Depending on the application, for DC to DC converters, people tend to like higher frequency to a certain point. But when it comes to higher current, people would rather have lower frequency and get more inductance at that high current level.
Eaton has some high current inductors that they come out with. Can you tell us a little bit about those?
Yes, we actually have a very diverse product line for high current inductors for both categories, the ferrite and the pressed powder inductors, so we can service a wide range of market segments. One of the ones that we focus a lot is the automotive industry. We're seeing a lot of requirement for higher power. A lot of these high current inductors serve to support that type of growth in electronics and automobiles. And for a lot of the ferrite category, a lot of the high current ferrite structures that we have, we support more about the computer industry because the higher frequency needs of these high current inductors. So kind of tailor our high current product line to service all these market segments.
Gotcha. That's interesting, Steve. Thank you for that.
Thank you.